In this video, we're going to be talking about naming and drawing alkanes. So remember the table Q showing us the homologous series? The very first column on table Q are the alkanes, and that's what we're going to learn how to not only name but draw. So alkanes contain only single bonds. They're the only homologous series that is just single bonds, so that means they are saturated. They have the general formula CnH2n plus 2. So N equals the number of carbon atoms, so to find the number of hydrogen atoms, you just double it and add 2. So here's an example question. If an alkane molecule contained 10 carbon atoms, what would be its molecular formula? So the answer is C10H22. So 10 times 2 is 20, plus 2 is 22. So 10 carbons, because it's the problem said, and 22 hydrogens. Okay, so here's how you name organic compounds. We follow the IUPAC rules. That's the International Union of Pure and Applied Chemistry. That's the governing body that decides the rules, the worldwide rules that everyone will follow for how to name organic compounds. And it's slightly different than some of the other naming systems that we've learned. So these rules are all based on the number of carbon atoms in the molecule. So the prefix that we give the name of the molecule indicates the number of carbon atoms it contains. And then the suffix is for an alkane will be ane, so ane for alkane. So here is a nomenclature chart showing you the number of carbon atoms, the prefix, the name, and the molecular formula. So if you just have one carbon atom, the prefix is meth, and a alkane that only had one carbon would be named methane, and its general formula would be CH4. So one carbon, double that, plus 2 would make 2 plus 2 or 4 hydrogens. So there's the molecular formula for a methane. If you have 2 carbon atoms, the prefix is eth, the full name would be ethane, and the formula is C2H6. 3 carbon atoms, the prefix is prop, the full name is propane, and the formula is C3H8. 4 carbon atoms, the prefix is bute, the name would be butane, C4H10. 5 carbon atoms is pent, pentane, C5H12. 6 is hex, the name would be hexane, and the formula is C6H14. 7 is hept, the full name would be heptane, and the molecular formula would be C7H16. 8 is oct, octane, C8H18. 9 is known, nonane, C9H20. And 10 is dec, decane, C10H22. So you notice the names all end in ane because they're all alkanes, all single bonds. The prefix matches the number of carbon atoms you have, and this you don't need to memorize because it's all on a reference table. And the general formula is that N2N plus 2. So, you know, any of these you analyze C8. So 8 times 2 is 16 plus 2 is 18 hydrogens. So they all follow the general formula for alkanes. So you won't get that chart that we just had on the last screen. You will get this chart. This is table P. All it simply shows you is the prefix and the number of carbon atoms. But this can be enough to figure out how to draw or how to write a formula for your organic compound. So keep table P handy. You will most likely memorize this as you do more of these organic compounds, but in the beginning you'll probably have to rely heavily on table P to help you with the number of carbon atoms. Okay, so let's practice naming some alkanes. So for this first one here, I have 2 carbons in a row. So the prefix for 2 carbons is eth, and I know it's an alkane because this is a saturated hydrocarbon. All I see is single bonds, or if I analyze the formula, C2H12345 that's 2N plus 2. That's an alkane general formula, so it is ethane. Okay, the next one I have 1, 2, 3, 4 carbons. So the prefix for 4 carbons is but, and again, all single bonds. So I would give it the suffix ane. So this is butane. That's the gas that's in your Bunsen burners that we use in lab. Okay, next. Much longer hydrocarbon here. We need to count the carbons. 1, 2, 3, 4, 5, 6, 7, 8. So the prefix for 8, according to table P, is oct. And again, this is a saturated hydrocarbon, so it is obviously an alkane. So this is octane. Okay, we need to be able to go in the other direction as well. So if I give you the name of an organic compound, you should be able to draw it. So our first one is methane. So the prefix meth will tell me how many carbons there are. So meth is 1, and it's an alkane. So that means it's all single bonds. So I just have 1, 2, 3, 4 single bonds going to hydrogens. Again, we're not drawing the hydrogens. It's typically okay to leave hydrogens off on organic drawings. Next we have pentane. So pent, the prefix according to table P, is 5. So first I'm going to attach all of my carbons in a row. 1, 2, 3, 4, 5. And then I'm going to fill in all the hydrogens. So each carbon needs to have 4 bonds on it. So this first carbon is going to need 1, 2, 3. Oh, no, I'm skipping. There should be a third one here. Or you can just go around and fill them all up, which is what I'm doing here. So each carbon is bonded in all 4 directions, either to another carbon atom or 2 hydrogen atoms. So this would be 3 hydrogen atoms. Every carbon in the middle will be bonded to 2 hydrogen atoms, and this one at the end would be 3 hydrogen atoms, for a total of 12. Okay, next and slightly more complicated example is drawing branch chain alkanes. So these are alkanes that have branches off of a larger chain in the middle. So here are the rules for naming them. So rule number 1 is the longest carbon-carbon chain is what we call the parent chain, and that's where you're going to get your prefix from to use in the name. Then you number the carbons either left to right or right to left so that the branch will have the lowest number. Now the reason we do this is because these molecules in reality are 3-dimensional. So they could flip 180 degrees and still technically be the exact same molecule. So we number them left to right or right to left. Whichever way will give the branch that's on our alkane the lowest possible number. We give a position number to the branch. And we use prefixes like di or tri if there's more than one branch. We alphabetize the branches, not the prefixes. And we use proper punctuation like dashes and commas and things like that. So this list of rules by itself doesn't make a whole lot of sense. It only starts to make sense the more practice problems you do. So let's make sure we've written this down in our notes and then move on to some practice problems. Okay. Oh, actually, before we move on to some practice problems, let's talk about how we name these side chains. So these side chains are technically what's called an alkyl radical. So this is when an alkane molecule loses a hydrogen molecule and then can be attached to a much larger chain. So like I said, these are often the side branches on branch chain alkanes. So here's how you name them. So this is an alkane, this is methane. It is a carbon atom bonded to 4 hydrogen atoms. But if I lose one of these hydrogen atoms, so if this goes away, instead of CH4, this is now CH3. So the way you name an alkyl radical is you drop the ending, ane, and add an eel. So this is methyl, or a methyl group. So if I had a 2 carbon long alkane molecule like this, we would name it ethane. C2H6 is ethane, but if I lose one of these hydrogen atoms, and it is now C2H5, I again drop the ending ane and add YL. So this is ethyl. And you can probably guess where we go from there. If I had 3 carbons, it would be propyl. If I had 4 carbons on an alkyl radical, it'd be butyl. But for Regents chemistry, your alkyl radicals tend to be very small. So methyl and ethyl are the most common ones you'll see. Okay, so let's do some examples here. Let's name this branch chain alkane. Okay, so I have 3 carbons in my longest carbon-carbon chain, 1, 2, 3, and it doesn't matter if I count 1, 2, 3, or if I go from right to left, 1, 2, 3, or if I go this way, 1, 2, 3. I still have 3 in a row, no matter which way I count as my longest chain. So I'm going to use the prefix prop. Okay, now it's an alkane. I know this because it's all single bonds. It's a saturated hydrocarbon, so this is a type of propane, but it has a alkyl radical group here. Now it is a methyl group because it's a CH3, so 1 carbon alkyl radical on the side here, so that's methyl. And then I need to give it a number, and it is on the 2nd carbon. So this is 2-methyl propane. Now it doesn't matter if I numbered left to right, 1, 2, 3, or if I numbered right to left, 1, 2, 3. It's 2-methyl propane no matter which way you count. Okay, here's another one. So my longest carbon-carbon chain is 4. 1, 2, 3, 4. So I'm going to have the numbers showing here, showing I have 4 in a row. This is also helpful when it comes time to number my side chain. I can see it's on the 2nd carbon. So 4 carbons in a row will give me the prefix but. Again, it's an alkane because I have all single bonds. And now it's time to name my side chain. So I have another methyl group here, CH3, and it is on the 2nd carbon. So this would be 2-methyl butane. Okay, now what if I moved it over here? What would its name now be? Well, it actually wouldn't change. So this would also be 2-methyl butane, because now I will number from the right to the left to give my side chain a lower number of 2 rather than a number of 3. In reality, there's no difference in a 2-methyl butane or a 3-methyl butane, because like I said, these things are 3-dimensional. If you flip it around, it's still the same molecule. Okay, next one. I have 2 chains going on in this one. So we still follow the same set of rules. I'm going to find my longest carbon-carbon chain. And it doesn't matter which way I count, it is 3. I have 3 carbon-carbons in a row. So I'll have the prefix prop. It is a propane because it's all single bonds. And now I need to name my side chains. So I have a side chain here, and it's a methyl group, and I have a side chain here, it's also a methyl group. So if I have 2 methyl groups, I need to designate that with a di. So this is a dimethyl, just showing that I have 2 methyl groups. And then I need to give it a number. So this methyl group is on the 2nd carbon, and this methyl group is also on the 2nd carbon. So the name for this would be 2, 2 di, because I have 2 methyls, or dimethyl because they're both methyls and I have 2 of them. Prop because my longest is 3 in a row. Ane because the whole thing is a alkane. So 2,2-dimethyl propane. Okay, and we also need to go in the other direction. So if I give you the name, you need to be able to draw it. So here are the rules for drawing. So we find the parent with the ane name. We number the carbons on the parent and identify the subsequent groups and give them the lowest number and attach them. And then you add the remaining hydrogens at the end to make sure everyone's octets are happy. Okay, so here is our first example, 2,2,4-trimethylpentane. So we're going to find the longest parent with the ane ending, and that's pent. So that means I have, according to table P, 5 carbons in a row. So let's draw our 5 carbons. 1, 2, 3, 4, 5. Okay, and then if I look at the beginning of the molecule's name here, trimethyl means I have 3 methyl groups. And these numbers will tell me where they are. 2, 2, 4 means I have a methyl group on the 2nd carbon, another methyl group on the 2nd carbon, and then the 3rd methyl group is on the 4th carbon. So it doesn't matter, it's up to you which way you want to number. All things being equal, I usually number from the left to the right. So 1, 2, 3, 4, 5. So this will be my 2nd carbon, and I will put a methyl group here, CH3. I have another methyl group on the 2nd carbon, so that must be pointing down in this direction. So here's my 2nd CH3. My third methyl group is on the fourth carbon, so that is 1, 2, 3, 4, this one here, and it's your choice whether you want to draw it pointing up or pointing down. It does not matter. Again, these molecules are three-dimensional. So mine's going to be pointing up, so I'll have my third methyl group here, and I have all of my side chains. So my last step is to fill in all the rest of the hydrogens to make sure these carbons are happy. So everyone's going to have 8. So this one only has 2. So I need 3 more bonds. And in reality, these are going to hydrogens, which I am not drawing. So there's my drawing for 2,2,4 trimethylpentane. Okay, next let's try to draw 3-ethylpentane. So again, I have another pentane. So according to table P, that's 5 carbons in a row. So there's 1, 2, 3, 4, 5. I have a side chain, and it is an ethyl group, and it is on the third carbon. So I'm going to count 1, 2, 3 in, and I will draw an ethyl group. So ethyl means I have 1, 2 carbons. So it's a 2-carbon long alkyl radical, so C2H3. And then last step is fill in all of your hydrogens. So there is 3-ethylpentane. Okay, next, 2,3,4 trimethylhexane. So my longest chain is hexane. So that means I have 1, 2, 3, 4, 5, 6 carbons in a row in my longest carbon-carbon chain. I have another trimethyl. That means I have 3 methyl groups, and they are located at the second, third, and fourth carbon. So it doesn't matter which way you number, it's up to you. So I'll go left to right. So on carbon number 2, I'll have a methyl group, a CH3. On carbon number 3, I'll have my next methyl group. Mine's going to be pointing down. Yours could be pointing up. It does not matter. I'm just pointing it down to kind of save room, save space. And my last methyl group is on the fourth carbon. So that's the next one over. I'll have that pointing up, another CH3. And then lastly, we fill in all the hydrogens to make all the carbons happy. So there is 2, 3, 4, 2, 3, 4 trimethyl, because I have 1, 2, 3 methyl groups. Hexane, because I have 1, 2, 3, 4, 5, 6 carbons in a row. So in summary here, there are 3 categories of hydrocarbons, and you can find them all on table Q. So far we've learned about alkanes. Alkanes are the easiest to identify because they just have single bonds. They are what's considered saturated hydrocarbons. They have the general formula CnH2n plus 2. You can look that right up on table Q. You don't need to memorize it, but you might need to use it to find the formula for a alkane. The prefix in the name of an alkane comes from the number of carbon atoms it contains, and you can find that on table P. Again, have it handy early on, but you'll be using this so often you'll probably memorize these shortly. The suffix for an alkane all end in -ane, and you can be reminded of that right on table Q. It'll tell you. And the rules for naming and drawing alkanes are kind of complicated, but you need to learn them. Basically, you just need to practice. Now, this is very difficult for the novice at first, but we're going to be doing a lot of practice in class. And if you are really lost right now, don't worry, you're probably not alone. Again, we're going to practice this until we master it. But if you're having any troubles, please come see me for help.